All right, let's talk about something we all do, but probably never really think about. Deep inside your brain, there's this tiny command center making a huge decision for you multiple times a day when it's time to, well, use the bathroom. I mean, it seems super simple, doesn't it? You feel that urge, you find a restroom, and that's pretty much it. But what's really going on behind the scenes is this amazing, incredibly complex dance of nerves and muscles. So let's pull back the curtain and meet the real boss.
So yeah, who is in charge? Well, it turns out there's this dedicated mission control for the whole shebang, and it's got a pretty cool scientific name.
Okay, here it is, the Pontine Micturition Center. But let's just call it the PMC, because that's way easier. Now, this is a tiny but seriously powerful bundle of neurons tucked away deep in your brainstem. Think of it as the ultimate switchboard, the one that gives the final, official green light to go.
So what does this PMC actually do? Well, it's juggling three really important jobs. First up, it's a master coordinator. It has to perfectly sync up your bladder muscle squeezing at the exact same moment your sphincter muscle relaxes. If that timing is even a little bit off, the whole system just doesn't work. Second, it's the main switch, literally flipping your body from storage mode to emptying mode. And finally, it's a critical relay station, kind of like an air traffic controller, managing all the messages flying between your bladder and the big bosses in your brain. Okay, let's zoom in on that switching job, because honestly, that's its main gig. It's all about managing two totally opposite states, storing and going.
Think about it. When you're in storage mode, your bladder muscle is all chill and relaxed, so it can fill up, and the sphincter muscle is clamped down tight, keeping the gate locked. But the second the PMC shouts, "Go!" it completely flips the script. The bladder muscle squeezes down hard, and the sphincter muscle opens up. It's this perfectly timed push-pull system, and it has to work just right. So the big question is, how does the PMC even know when to flip that switch? It's not just random. It all starts with a little message, an urgent memo, sent from the front lines. Let's actually trace that signal's journey from start to finish.
Okay, so step one, your bladder starts to fill up. As it stretches, these little receptors in the bladder wall are like, whoa, it's getting full in here, and they shoot a signal straight up your spinal cord to your brain. Then comes the conscious part. Your brain asks, hey, is now a good time for this? Are we near a bathroom? If the answer is yes, then the go order gets sent down to the PMC. The PMC snaps into action, tells the sphincter to open up, and orders the bladder to squeeze. It's this incredible, super fast 5-step chain reaction.
But here's a really cool part. The PMC, for all its power, isn't a lone wolf. Nope, it's a super important player, for sure, but it's part of a much bigger team, a whole chain of command.
So you can think of the PMC as the field commander, the one on the ground actually executing the mission, but it gets its orders from higher management, and it coordinates with other specialists to make sure the whole operation is smooth, safe, and, socially appropriate. So let's meet the rest of the team. Up top, you've got the cerebral cortex. That's the CEO. It makes that final, conscious decision. Yes, go now, or nope, hold on a bit longer. Its messages get passed down through something called the periaqueductal gray, or PAG. You can think of the PAG as the CEO's executive assistant, making sure the message gets to the PMC loud and clear. And finally, way down in the spinal cord, you have the sacral micturition center. This is like the basic automatic reflex operator. A lot of animals just have this simple reflex. But what's so amazing about us is that our higher brain centers, our CEO, can override that. And that's a huge evolutionary advantage that turns a simple bodily function into something we can actually control. So when you step back and look at this whole system, what's the one big takeaway here? It's all about coordination. Just absolutely perfect, seamless coordination.
That's why calling the PMC a vital switch is so spot on. Its real genius isn't just making you go. It's making sure you go at exactly the right time and place when you give the okay. And that's the magic trick, right? That's what elevates this from a simple reflex to a controlled action that lets us navigate our complicated world. Which leads to a really important question. What happens when this perfect system breaks down, because of an injury or a disease? Well, understanding this whole biological circuit, this bathroom switch, is absolutely crucial for treating all sorts of medical conditions. And honestly, it just gives you a whole new level of appreciation for the incredible, silent work your brain is doing for you every single day.